In class, we're starting a new module regarding solid waste and hazardous waste management. In this tutorial, I'll be providing an overview of solid waste management. Recall from the beginning of class that civil and environmental engineers can be defined by this quote from the American Society of Civil Engineers. The key for this quote is that civil and environmental engineers provide infrastructure, and solid waste management demands infrastructure. This is a picture I provided at the beginning of the course regarding landfills, and that is one of the most common fates of trash in the United States. And this was a picture that I provided to show you what could happen if civil and environmental engineers don't provide this infrastructure. So these pictures are provided from Italy. Before we get into how landfills are designed or some of the alternative fates for trash, let's get clear the different definitions. Solid waste is a generic term that includes all items that are thrown away. The EPA has a very broad definition for solid waste. It is any discarded item, anything that is destined for reuse, recycle, or reclamation, and it includes hazardous waste. What it does not include is radioactive waste and in situ mining waste. These are regulated differently. Now, as we discuss solid waste, we sometimes also use definitions of garbage and rubbish. Some students think that these are just the American and the English words for garbage, but they are actually different definitions. Garbage includes any waste from cooking and the preparation of food. I like to remember the definition of garbage by thinking what could go down a garbage disposal, down your sink. And that is mostly food scraps. Rubbish includes anything that's combustible and non-combustible that does not originate from food. Combustible items are paper, cartons, yard trimmings, etc., and non-combustible is metals, dirt, and crockery. So a residence produces both garbage and rubbish. The distinction here can be useful when we consider composting, because garbage is typically combustible, but may include some pathogenic or public health concerns if you think about salmonella from chicken or eggs. Rubbish includes items that are not compostable. When we discussed water supply, I had you think about the typical per capita water demand for a person. In the United States, that was about 70 gallons per person per day. As we consider solid waste management, it's also useful to think of a per capita solid waste production. These are 2003 estimates from your textbook, but the U.S. national average in 2003 was 2 kilograms per person per day, and there are 2.2 pounds per kilogram. So each person in the United States, on average, produces 4.4 pounds per day per person. This number varies for different cities. In California, the per capita solid waste production is actually much higher, and in rural communities such as Wilson, Wisconsin, it's much lower. And I'm going to talk to you about this, and I'm going to discuss this urban versus rural phenomena as the difference in convenience living. Before we talk about convenience living, this is a graph from your book, and it shows megagrams per day of solid waste production and population. So if you start with that average of around 2 kilograms per person per day, and you multiply up by the number of persons, you see that you have this linear line. The typical range in the United States is this gray area. As our population grows across the world, we'll produce an increasing amount of solid waste that has to be dealt with. Now, there is an urban versus rural aspect to how much solid waste is generated, and as I said, as population grows, the mass increases. Here I'm presenting some statistics of the amount of solid waste produced in 1960 to 2003. And across this time, you have an increase in population, but you also have an increase in the rise of convenience foods. And so if we divided 80.1 by the population present in 1960, we would have a much lower per capita solid waste production than we do in 2003. And just so you understand the unit here, a teragram is 1 times 10 to the 12 grams. And I'm going to show you some pictures here that I find telling for this problem. So in 1960s, we had the invention of the TV dinner. And I really love this advertisement for TV dinners. It really speaks to my life. So here we have this idea that a woman could now work and still make dinner for her family because of this convenience food. And let's look at the packaging associated with this. You have the box, you have the plastic tray, and you have one for each family member. And so this is fabulous for the working mom, but now produces more solid waste. Now if we think about fast food, and some of you may have read the book Fast Food Nation, which is a frightening book actually, but we have this idea that now we have fast food, convenience food. We don't have to slave in the kitchen. We can go pick up dinner anytime. And I want to be careful. I don't want you to think that this is unhealthy options, but healthy options also create lots of solid waste. And we can even argue that as we think about healthy alternatives, we create even more solid waste packaging. Now we have our apples in a plastic bag. Here are some more of those healthy options. Sushi comes in this container. Now we have these 100 calorie packs, which have a tremendous amount of packaging. Our salads are packed in wrappers, and our applesauce. And this is my argument that the increase of solid waste production is really spurred by an increase of convenience living. And that is the reason we see more urban production than rural production. Rural communities might not have as many options for packaging and fast food as the urban environment does. This is a pie chart of the different contributors to solid waste. Percentage of mass, the biggest part of this pie chart is paper. The second is yard trimmings and food scraps. In total, this accounts for over 50% of the solid waste production in the United States, and this is all combustible and to a large extent compostable. And so as we discuss in the next lesson plan some of the options for disposal and treatment of solid waste, these distinctions will become important for incineration and recycling. As we look to recycling, metals, glass, and wood to some extent can all be recycled fairly easily. As we move toward the discussion of those management options, we should keep in mind the first objective is to remove discarded material from inhabited places in a timely manner to prevent the spread of disease, to minimize the likelihood of fires, and to reduce aesthetic insults or smells. This is our public health consideration, to protect public health. That is always our primary goal. The second objective is to dispose of the discarded material in a manner that is environmentally responsible. And this can include any of the three options listed here. Landfills. Landfills are by far the ultimate fate of most of our solid waste. Over 50% of our solid waste ends up in a landfill. And this can be argued to be the least environmentally sustainable method, but we will have to engineer these systems to create a safe environment. The second and the third option is incineration and composting. In the United States, incineration is our least favorable disposal option. Only about 14% of our waste ends up in incinerators, but in Europe, this is one of the most common management options. with composting and recycling. And we'll discuss in class why the U.S. tends to favor landfills and Europe tends to favor incineration. Now, both the U.S. and Europe rely heavily on composting and recycling. Composting and recycling is a method to process waste to recover resources, and those resources can be either material or energy. In the next lesson plan, we will discuss incineration and composting, and in 2 lesson plans from now, we will discuss landfill engineering by itself.